This is section 8.1. We're going to talk about right triangle trigonometry. So we're going to review SOHCAHTOA. We're going to talk about solving a triangle, and we're also going to talk about angles of elevation and angles of depression. Now, for this lesson, we are going to be using a calculator, so you're going to want to make sure you have that ready. So just to review, SOHCAHTOA. Remember, SOHCAHTOA is only used on right triangles. If we have an obtuse triangle or an acute triangle, we cannot use SOHCAHTOA. So sine of some angle is opposite over hypotenuse. Cosine of some angle is adjacent over hypotenuse. And tan of some angle is opposite over adjacent. So SOHCAHTOA is what we're going to learn today. Now in example 1, this is an example of solving the triangle. So when we solve a triangle, we want to find all three angles and all three sides. And it's also important how we label this right triangle. So we have a right triangle. C is the right angle. That's almost always the case. And then we have a little a and a little b. So depending on where we place little a and little b, that's going to dictate where angle A and angle B are. So just as a general rule of thumb, the angles are going to be labeled with capital letters, and the sides opposite those angles are going to be labeled with the corresponding lowercase letters. So I'm going to start by drawing a right triangle here. So here's my right angle, and right angle is our angle C. And then across from opposite to that right angle is side C. Right? And so then I'm just going to put angle A on the bottom corner and angle B on the top corner. So this bottom acute angle here is angle A. So if I look at the side opposite angle A, that's where little a is. And we were given the measure for little a. Little a is 111.4 centimeters. Right? So then if angle B is up here on the top, then the side opposite that angle B is what we're going to label side little b. And little b was given to be 125.3 centimeters. So when we solve a right triangle, we're looking for all three angles and all three sides. So I'm just going to start a legend up here for angle A, angle B, angle C, and I'll fill them out as we figure them out. And then little a, little b, little c. Okay. So we have one angle that was given. That's angle C, we know to be 90 degrees. And two sides were given. So I'm going to go ahead and fill those out on my legend. Right. So we need to find angle A, angle B, and side C. So I'm going to go ahead and start with side C first. Little c is the hypotenuse of this triangle. And so since we were given little a and little b, we have the two legs. And so Pythagorean theorem is going to work really well here. So to solve for side C, we're going to get a squared plus b squared.
Fire in Bates Hall. Attention on post. Attention on post. Attention on post. A fire alarm has been activated in Bates Hall. All building supervisors take an accurate muster and establish communications with the commandant on channel 3. All personnel evacuate and remain clear of the area.
Okay, So obviously I'm on campus. All right, here we go. I'm going to square 111.4, and I'm going to square 125.3, add the two numbers together. So I'm going to get 28,110.05 is c squared. So if I square root that, that will give me the value of little c. Alright, so since a and b are rounded to one decimal, I'm going to go ahead and round this to one decimal. So I have 0.66, so I'm going to round that 6 up to 7. So I'll get 167.7 centimeters. So I'll put that answer here. Alright, so now we can solve for angle A and angle B using our trig functions, using our SOHCAHTOA. Right? Now, I am going to use little a and little b since they are given. And so I'm going to use the trig function that only uses the opposite and the adjacent sides. I'm not going to use the hypotenuse just in case I made a mistake here. All right? So let's go ahead and solve for angle A first. So angle A is here. And so if I want to use little a and little b, that's opposite to angle A and adjacent to little a, and so tangent is the function that uses opposite and adjacent. So I'm going to write an equation here. Tan of angle A is equal to the opposite side over the adjacent side. And I need to solve this equation for A. And so in order to do that, we're going to cancel tangent by applying tan inverse to both sides. So when I type this equation in my calculator, I want degrees as my answer. So right now I'm in radian mode, so I'm going to go ahead and change that to degrees. And then type in tan inverse of 111.4 divided by 125.3. That gave me 41.6 degrees. All right, now we can use another tangent function to solve for angle B, but I am going to use the complementary angle and solve for angle B by knowing that A and B have to add up to 90 degrees. And that's because in the triangle we have 180 degrees. Angle C is 90 degrees, so these two added up have to be at 90 degrees as well. So angle B, I'm just going to do 90 minus 41.6 because A and B add up to 90 degrees. And so 90 minus 41.6 is 48.4. So here's my legend solving this triangle. Now I'm just going to spot check real quick that the smallest side is across from the smallest angle and the larger side is across from the largest angle, just to make sure. So 114 is the smallest side, angle A is the smallest angle, and these two are the largest. Okay, so the B's are in the middle, and we're good. Okay, so solving the right triangle, just find all three angles and all three sides, but make sure you're labeling your triangle with the lowercase letter opposite the capital letter for the angle. All right, example 2, I went ahead and wrote in advance. So if you want to take some time, pause the video, copy this down, that would be great. All right, so this example is talking about an angle of depression, right? So I just kind of like to talk about angle of depression. So an angle of depression starts from a horizontal line and is rotated down. So I'm just going to draw a generic angle of depression here. Right. So if I have some point in space here, I have a horizontal line of view coming from that point in space. And so the angle of depression is going to start from this horizontal line and rotate down. Okay, this is the angle of depression. So that would happen in this example when someone is on a cliff and looking down at a ship, okay? And so the angle of depression, though, is from the horizontal line of the person and then rotating down. So vice versa, we have an angle elevation, right? And so that happens when we're looking up. So say we have a point in space, okay, or where a person is, and there's this horizontal line of sight from that person. So if this person were to be looking up, then we have an angle of elevation being from this horizontal line rotated up to get to that line of sight. Right. So make sure you're labeling the angle correctly when you draw this picture. All right, so we have a 500-foot cliff. It's dropping vertically into the ocean. That's going to create a really nice 90-degree angle for us to work with our right triangle. So here's my cliff, and here's my ocean, okay, and this is 90 degrees. The cliff is 500 feet high, so I'm going to look at 500 feet. Right? So the angle of depression from the top of the cliff to a ship is 42 degrees. So I'm going to draw a ship out here from the top of the cliff. Okay, so here's my point. And so if I were to kind of draw a dotted horizontal line, this is where the angle of depression is going to emanate from. So the angle of depression is 42 degrees. Right? So from the horizontal line rotated down, that's 42 degrees. Right? So if I were to kind of draw a triangle here, notice that 42 degrees is not inside the triangle. So we kind of have to figure out what this angle is, right? Now, the cool thing about angle of depression is we have a horizontal line of sight. We have a horizontal ocean, okay, because it's level. And so two parallel lines, when they're cut by a transversal, the alternate interior angles are equal, right? If you remember some geometry. So that means from the cliff rotated down to the ship, that angle of depression is going to equal the angle of elevation from the ship up to the cliff, right? So this here is also 42 degrees, right? So an angle of depression from the top of the cliff to the ship is 42. The angle of elevation from the ship up to the top of the cliff is also 42. Right? So that's one way to figure out one of those interior angles. Another way is to know that this angle of depression and this angle here inside the triangle are also complementary, meaning they have to sum up to 90 degrees, right? Because we have a vertical line meeting a horizontal line. So I know this angle here is also 90 degrees, All right, so 90 minus 42 is 48. So now I have both of my interior angles. Okay, I have all three of my angles. Okay, the question is, how far offshore to the nearest foot is the ship? Okay, so how far away from the cliff is the ship? So I want to know this value. So we weren't given the hypotenuse at all. We weren't asked for the hypotenuse. So the trig value, or the trig function that we're going to use, is going to be the one that uses opposite and adjacent sides. So we could use tangent, or we could use cotan. Right? So I think, let's see, I'd like to keep x on the top. So I could either do cotan of 42 and do adjacent over opposite, or I can do tangent of 48 and do opposite over adjacent. I'm going to opt for the tan function of 48 degrees. So I have tangent of 48 degrees is equal to the opposite side over the adjacent side. So if I solve this for x, I just need to multiply both sides by 500. And if I plug this expression into the calculator, I have my solution. So 500 tan of 48. Remember, these are degrees, and so we want to make sure we're in degree mode. All right, so I got 555.306. So how far offshore to the nearest foot? Looks like we're going to be 555 feet, okay, from the shore or from the cliff. All right, so just remember your angle of depression is sometimes outside your triangle you want to use. So just some geometry there, or some complementary angle knowledge will help you figure out what the angles are inside of the triangle. Okay, example 3. A security camera. Oh, go ahead and pause the video and write this one down as well. It's a little bit longer. Alright, so we have a security camera in a bank mounted on a wall 10 feet above the floor. We're looking for the angle of depression this time. Okay, if we're to direct the camera to a spot 7 feet above the floor. So from the camera down to our spot, it needs to kind of go down 3 feet, right? So that's why we're using that angle of depression. So I'm going to draw a kind of a crude drawing here. Here's my wall. Here's my floor, which creates this nice 90-degree angle. Right, here's my security camera on the wall. And so that security camera is 10 feet. Right. So now I want to draw the spot that we're going to direct this camera to. Right. So the camera is to be directed to a spot 7 feet above the floor and 13 feet from the wall. So we're going to go 13 feet out, and then we're going to go 7 feet up, and this is where I want to direct that camera. Okay, so the camera, has this nice horizontal line of sight, but I want to tilt this camera down to where it's pointing at this spot here in space. Right? So, and it's asking for the angle of depression. So if I start with this horizontal line of sight of the camera and start tilting that camera down to that spot, right, this is my theta that I'm looking for. Okay, that angle of depression from the horizontal line rotated down. Right? So I'm going to kind of use this upper triangle here. to solve this problem. Because this upper triangle, has a vertical and a horizontal line too. So this is a 90-degree angle. Right? So in this upper triangle here, I know that this horizontal distance is 13 feet because it's 13 feet out. I know this shorter distance here is 3 feet. And the way we know that is because it's 7 feet up. Okay, the camera was 10 feet up, so 10 minus 7 is 3. Right? Now I'm looking for this angle. Again, we weren't given any information for this hypotenuse. So the trig function, our right triangle trig here, is going to use angle theta, okay, and then the opposite and the adjacent side to theta. So it looks like tangent is what we're going to use yet again, right? So if I were to set up an equation, tan of theta is opposite over adjacent. So the opposite side is 3, and the adjacent side is 13. And I want to solve for theta. So to solve for theta, we're going to tan inverse both sides. So if I plug tan inverse of 3/13 into the calculator, I get an angle of depression 12.99. I'm going to go ahead and round that, okay, to 13 degrees. So the angle of depression should be 13 degrees. We need to tilt that camera down 13 degrees to get it pointed at the correct spot. All right, so when you solve these, just find your right angle, okay, and find the right trig function to use, and you'll be good. All right. One more example, example 4. So example 4 reads, find the 6 trig functions of the angle theta in the figure below. Okay, so theta was in here in the bottom corner. And so we really need all 3 sides here. Now 1 in rad 3 makes you think it's a special triangle, but rad 3 isn't the hypotenuse in that case. And so in order to solve for this other side here, we are going to have to use Pythagorean theorem. 1 squared plus b squared equals rad 3 squared. So if I solve this, 1 plus b squared equals 3. Subtract 1 from both sides. B squared equals 2. Square root b equals rad 2. Right? And we're just going to use, instead of doing plus or minus here, we're just going to use our positive answer. Okay. So the 6 trig functions for theta is sine, cosine, tangent down the left. And then we're going to get cosecant, secant, and cotangent on the right. So sine of theta, using our SOHCAHTOA, opposite over hypotenuse is 1 over rad 3. And so if I were to rationalize this, I get rad 3 over 3. Cosine of theta, the adjacent side over the hypotenuse, so we're looking at rad 2 over rad 3. And if I were to rationalize this one, we would get rad 6 over 3. Tan of theta, opposite over adjacent, 1 over rad 2. And if I were to rationalize this, we'd get square root of 2 over 2. Now, when we do cosecant, secant, and cotan, we know cosecant is the reciprocal of sine. But don't reciprocate rad 3 over 3 because then you'll have to rationalize that again. Go ahead and just go with your 1 over rad 3, right? And reciprocate your answer before you rationalized. So 1 over rad 3 is reciprocal as rad 3. Right. Now this one we are going to have to rationalize either way because the unrationalized form had a square root on the top and the bottom, right? I'm going to go ahead and go with this unrationalized one. I'm going to flip that. Okay, rad 3 over rad 2, because if cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. And so we're going to get the rationalized form square root of 6 over 2. Alright, cotan, we can flip this, or we can go ahead and do our ratios, right? Let me go ahead and, this one is hypotenuse over opposite, secant is hypotenuse over adjacent, and tangent is adjacent over opposite, right? So I could just look at the triangle here. For theta, the adjacent side is rad 2, the opposite side is 1. Right, so I'm just going to get rad 2. Okay. And so that is all you need to know to complete 8.1.